Hi everyone. Next section is 2.3 from KC2 of integrated 3. This is on nets and volume. Now a net is a 2D flat version of a 3D shape. Okay, we can think of this as unfolding a 3D shape to see what we get. Okay, so the easiest way to show you this are through visual cues, and if you were in class, we were able to play with those 3D models that I gave you guys at your desk. If you weren't, then it's going to be a little harder, but we do have some online visuals that are part of your Teams page. So if you want to take a look at those links, you are more than welcome to. So the first example that we're going to go over is a cube. What does the net of a cube look like? Okay, so the first thing I'm going to do is draw a cube. Okay, so we can visualize that cube. Okay, so here's my cube, and I'm going to transform this into a net. Okay, so if I unfold this box, what would it look like? Right? So it would, now there are various ways to do this, but if you were in class, you were able to see this visually, and it looks something like this, like a T. And this is only one version of what this looks like. It is not the only version, okay? And that's it. This is my net. Okay, now my volume is the measure of how much space an object takes. Okay, so think about this as filling in or filling up the object, right? If I have a cylinder water bottle, I fill it with water. The amount of water that's in there is the volume. Okay, so we're going to be focusing on the volume of prisms. Okay, so prisms, like rectangular prisms or cubes or anything like that, to find that volume, all you have to do is multiply the length, the width, and the height together. So we are going to go ahead and find the volume of this cube. Okay, so I drew a cube, and I'm going to tell you that these are my measurements. The width is 5 inches, the length is 6 inches, and the height is 7 inches. Right, so according to my volume formula, all I would have to do is multiply the length, the width, and the height. So I get 5 times 6 times 7, which is equal to 210 inches cubed. That's it, right? And this should be review. It's nothing new. We've already learned it before. Okay, now I want you to find the volume given a net. Okay, so if you look at this net, this is also the net to a cube. It does look different than the net I gave you previously. Okay, again, and there is multiple ways to unfold a cube. This is just one of them. Let me go ahead and fix this really quick. I'm not sure why this is acting up a little bit, but anyways. So here's my net. I'm going to tell you that this measures 7 inches, this is 9 inches, and this is 8 inches. So all again I'm going to do is multiply the length, the width, and the height. So I have 7 times 8 times 9, which is equal to 504 inches cubed. And it is always going to be cubic units. Okay, you have 3 things that you're multiplying. So you will have an exponent of 3. Now, here comes the harder part, okay? This example is a little long, so you might want to pause it so that you can write it down on your notes before I move on from here, okay? So you have that. Suppose you have a piece of paper that is 11 inches long and 8 inches wide. You're trying to make a box without a lid, so you cut 4 squares from each corner. Then you're going to let X represent that length of the corner. write a function that represents the volume in terms of x. Okay, so I'm going to go ahead and highlight my important information. Okay, I have a piece of paper that is 11 inches long by 8 inches wide. This is important. I'm trying to make a box, but I cut off 4 squares from each corner. I'm going to let x represent the length of that corner. So I need to write a function for the volume. So my final answer is going to be volume is equal to something. Okay, so again, let's go ahead and try to visualize this. I'm going to draw a piece of paper, right? Here's my piece of paper, and all I know is that it is 8 inches by 11 inches. And I also know that we cut off squares at each corner, so these are gone now. And those measure x each. Now it is a square, so all of the sides are equal. So that means that this is x, this is x. All of these measure x. This is important because without this, we're not going to be able to write this volume equation. Okay, so I would make my folds right here along the dotted line so that I can create that box without a lid. So I would need to figure out what this measures, this width, and this length. Okay, all I know though is that the whole bottom is 8 inches and the whole length is 11 inches. So in order for me to figure out what this middle part is equal to, I need to take into account this x and this one. Okay, so together, including those two x's, is 8. Right? We know that the base is equal to, or the width is 8 inches. But I don't want to include those x, so I'm going to subtract those two x's from it to get my red width here. Combine your like terms, I get 8 minus 2x. So this is going to be part of my function. Okay, this is going to be part of my function. And now I need to figure out what this length is. And similarly, we're going to do what we did with the width, right? The length we know is 11 inches, but that's including this x from the top and this x from the bottom. So I'm going to subtract those x's as well, which means that I get 11 minus 2x if I combine like terms. Now, every time you are finding the volume of a prism here, we multiply 3 things, right? The length, the width, and the height. I have the width, I have the length. Now the height, you're going to have to visualize here. Okay, if I fold at the dotted lines, right, and at the red lines, my height is going to be right here, which I know measures x. So x is also going to be part of my equation, part of my function. Okay, so my function now is going to be v equal to x for my height, right, times 8 minus 2x for my width, times 11 minus 2x for my length. And I'm done. This is my final answer. I have 3 things that I've multiplied. Okay, now here it doesn't matter the order. Okay, think about it this way. If I multiply 2 times 3, I'm still going to get the same result as 3 times 2. Okay, so the order does not matter. What's in parentheses does matter though. Okay, and that's it. This is my answer. Okay, so let's go ahead and do another example. It's the same scenario as before, but the length this time is 16 inches long and 9 inches wide. And this time we cut off 2x from the corner squares. So again, I'm going to draw a rectangular piece of paper on here. And I cut off squares. So now these are gone. And those squares measure 2x each. That's all we know, that they each measure 2x. So in order for me to figure out the volume of this box, I need to figure out what the width of the dotted line is. And the length. Do this with another color. So the width and the length. Okay, similarly like before, to find my width, I know that the whole thing measures 9 inches and the whole length measures 16 inches. So my width, after the squares are gone, is going to be 9 minus 2x, because it's minus this 2x, and minus another 2x, because I have 2x on each side. Combine your like terms, you get 9 minus 4x. So this is my width. And do the same thing with your length. And my length would be 16 inches minus the 2x from the top that I don't want, that now is gone, and the 2x from the bottom. Combine your like terms, you get 16 minus 4x. So my equation for volume is equal to that 9 minus 4x, excuse me, times 16 minus 4x. But I cut off, this is going to be my height here, if I fold this up, I cut off 2x. So that is also part of it. And again, it doesn't matter what order you put this in, you will get the correct answer. It's the same thing. And that's it for nuts and volume.